If you've been to hard parts before, you know what we're about to do. We're about to go into what exactly happens really when JavaScript runs my code. And it's going to seem profoundly easy, too easy, way too easy. But we're going to understand it properly so that there's no mystery about what our code is doing when we get to all the hard parts. Okay, here we go. When JavaScript runs our code, here's some code. Two things I said it does. One, saving data, saving stuff, a quiz. When you play a quiz game, that data, your score, the last move you took, quiz questions, they're not like saved on the view, on the display. That's where they're rendered, that's where they're displayed. They're saved behind the scenes in JavaScript. Well, JavaScript therefore needs a store of data in which we store stuff. We call it the memory. And so with that in mind, David, what are we doing in this first line of code here in terms of memory, sort of storage space? I'm going to put everything we store over here. I'm going to call it memory. And I'm going to list it all off, boom, 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 stuff we're storing as we go. So on those terms, David, what are we doing here in the very first line of code?
We're declaring a variable named num.
Num.
And we're giving it the value 3.
3. Perfect. That means from now on, people, anywhere in my app, you see num, it's referring to that 3. Already, we can see 3 lines of code, that's OK. 10,000, this global memory, they sometimes call it global state, saved data. I don't know how good I feel about globally saved stuff like this. Anyway, nevertheless, up next, let's have Alex. Alex, what are we doing in line 2 here?
Declaring a variable named multiply by 2.
Okay, so a label multiplied by 2, and we're storing, associated with that label here, a whole block of code. It's in the kind of new style of writing, well, writing what, Alex?
Function.
A function. Excellent from Alex. A function. Now, it doesn't, my little nice keyword function that tells me explicitly it's code, but we know it's a function. It's got the little parentheses there. That's going to await an input. When we run multiply by 2, that'll be filled in. These are known as arrow functions. And then in the curly braces, when the code is run, that's the code that gets run. Now, that's line 2 that JavaScript does. It grabs all of that code and saves it. I'm not going to write all the code out, but it does save it all. I'm going to instead put a little box here with an F in, representing the code of the function. And that's the input-output. So what then, Anna, what is line 3 here? If that was line 2, saving multiply by 2 is the code, what's line 3, Anna?
It is declaring the variable name and setting it equal to will.
Declaring the constant name and setting it equal to will. Notice what Anna did there. She skipped over the body of multiply by 2. It's saved, it's done, it's finished with, unless we ran it. By the way, we never run it. It never gets done. It never even gets done. Excellent. Thank you to Anna. People, we've seen already 2 mega parts of what JavaScript does. 1, save stuff to memory. There it is. And the other, we didn't actually explicitly state, but I sort of hinted at earlier even, is we went through the code line by line. Finished on line 1, didn't stop, went to line 2. Didn't stop, went to the next line. That's known as the thread of execution. It threads its way down the page and executes each line of code as we go. A lot of the time it's saving stuff into memory, into store. Okay, those 2 things together are all you need really to run JavaScript. A place to store stuff and the processing power to go through the code line by line, the thread of execution. They're known together as an execution context. Context is a space to do something, well, to space to execute my code. All right, this is known as the global execution context. It's the one which we kick off when we start running all of our code. And by the way, anything in its memory is available for the whole rest of the application. This is in contrast to the local execution context, which is a mini version of this that we create when we run a function. Because what's a function but a mini program? People actually call it that, a sub-program of our overall program, a little mini app within our overall app. And that's exactly what we're going to do down here. We're going to execute code that we previously saved. We're going to run it. I've cut my name Will here, and we jump straight down instead to Virginia what. If you just start with the left-hand side there, we're declaring what after we've declared multiply by 2. We're declaring what on the left-hand side?
Output.
We're declaring the constant output. There it is from Virginia. Virginia, do we know what to store in output at this point? Does JavaScript know what to store?
Yes.
It does?
Well, not yet.
Ah, not yet. Because that right-hand side there is unfinished business. It's an expression that needs to be sent away to be executed. Thank you to David for our online audience. The whisper approach is excellent. It needs to be executed. I thought it was perfect. It needs to be executed, and we've got to get an output from it, a returned value. We're going to go and run the code of that function, and that little mini program, that little mini app, the multiply by 2 function, is going to give us out an output, some data, which will then be stored into, well, output. Perfect. So, for now, output is uninitialized. We don't even give it a value yet. It's blank. While we go ahead and run multiply by 2. Virginia, what symbols tell me that I've got to go and run multiply by 2 here? What are our core symbols in JavaScript to say, go do that code?
The parentheses.
The parentheses. She's spot on. And we're passing in what, Sam?
3.
3, none, which is 3. And so, everybody, we're executing a function. I already told you, when you execute a function, we create a little mini app to execute it. It's got a memory, and it's got the thread. So we only got one thread. It can only do one thing at a time in JavaScript, so it's going to weave its way in and start running the code of multiply by 2. To do so, we need something called an execution context. Excellent from Virginia. An execution context. It is basically what we just saw, but now a mini version. A mini version of our overall program just to run the multiply by 2 function. It's got 2 parts, the same as the main one. A thread of execution, that is, the computer goes through the code of this function line by line, and a little mini local memory just for stuff we store. So by the way, already we can see how nice functions are. They break our main program up into mini programs. The problem is there may be 10, 15 lines of code in here. And you've seen those functions? They ain't much easier to understand just because they're only 15 lines long. They're still full of computer code. And 15 of them, that's 15 by 15 dependencies. Like that line, 14 lines depend on that line, 14 lines depend on that line, 14 lines depend on that line. That's still pretty hard. But let's go into it for now. We'll see how to improve this, but let's go into it for now. What is the first thing inside this execution context, as it's known as? What's the first thing we pull into the execution context? I'm going to call on Andrew.
The variable?
The variable, talk it out to me.
The input number?
Input number. We don't call that a variable so much as a parameter. So I like to think of this as this overall thing is a constant. People do still call them variables. Variable literally means you can vary what you save in them. So I don't know if I want to call it that, but let's call it fine a constant, or you want to call it variable, fine. I like to split that into 2 parts. Label, value. Thing you can store, label for thing you store. When you're passing in an actual value to fill in a placeholder of your multiply by 2 function, as you say, to create a little local variable, that local label has got a special name. Virginia?
Parameter?
Parameter. Excellent. There it is. Parameter, argument, parameter, argument. Okay, Andrew, now we hit the body of multiply by 2. What do we do?
We create result.
We create result and assign to it?
Well, it executes, I guess.
Yeah, so assigned to result, input number, which is 3 by 2, which is 6. There it is. And the final line says return result. And because this is going to come up later, I want to stress what actually happens here is JavaScript holds return for now, because it doesn't know what to return. It knows it's got to do something, but hold that, and it looks at this and goes, what is this? And it gets it down to a value, because it can only ever return a value. And so it looks at this and goes, what is result? What's its value? Because that's definitely not a thing that's a value. That's definitely something that could be evaluated, turned into a value, but it's not a value in its own right. And what is its value, Virginia? Oh, actually, Jasmine?
6.
It's 6. And so what actually gets returned out is 6 out into what global label, Jasmine?
It gets put out into output.
Into output. She's spot on. And there it is. If you are experienced senior developers, you must be thinking, I can tell that multiply by 2 with the input of 3 puts 6 in output. But we hand wave, as professors at college used to say, you hand wave, like sort of understand things all the time. And if you build upon sort of understanding of the fundamentals, your next level up will only ever be sort of understandings. If you have true clarity over what the fundamentals are actually doing, your next level up, you can now build upon solid foundations. And that's what we're going to do today. All right, so our thread of execution comes out of this function. We exit it. This whole function is now deleted. Its local memory is deleted except for what got returned out. Again, I'm going to be a bit more specific here because it's going to come up again and again. The way JavaScript works is, I'll try and keep this clean, neat, but when the function's output comes out, that little bit there, the running of multiply by 2 with the input of 3, actually turns into, before we move on from that line, turns into the output. That's known as evaluates to. You get it, right? Value, turn into value. And remember, value, value, value. Even function saved code is value. Running of code, the command to run code, that's not a value. That's a command to go and try and get a value. It'll literally turn into the output. And now we can easily see output is assigned 6. Next line, we now come back out to global where we declare new output is the return value of running multiplied by 2 again. This time, people, with the input of everyone together? 10. Well done. By the way, front of Master's team, especially Mark, loves it when I do the group shout out because they have to turn on all your mics all at once. It's their favorite thing to do. All right. Let's create, on that note, we're executing a function multiplied by 2. What do we need to execute a function? We need a brand new execution context. That was horrible. We need the words execution context. I've done a few of these now. We need a brand new
Execution context.
Yeah, absolutely. Boone, especially, thank you very much for that great voluble clarity there. We're not going to actually create it. We'll just know that it's going to return out 20 into new output. I made you go through all that, people, and they didn't even draw it out, but whatever. And there it is, new output's 20. So, the thread of execution wove in. Actually, let me just use a different pen for the thread of execution. It wove in, it wove out, it wove in, and it wove back out. We didn't show the execution context here. We went into it. We came back out. I want to stress one other thing with this, which I don't usually stress at this point, but it's going to come up again and again. Multiply by 2, I saved it not saying what, I really should have called it actually this, multiply something by 2. And when I saved the code and multiply something by 2, did I determine what value I was going to, did I preset what value I was going to multiply by 2? Sam?
No.
No. Already I can start to see one of the core uses of my functions. Save it once, use it again and again in different scenarios with different data. When I run the function, dynamically, live, turn it into multiply 3 by 2. Dynamically, live, in that line, turn it into multiply 10 by 2. And it might turn out, people, that we don't just want to dynamically set some of our data when we run a function, rather than when we save it. Right? When we saved it, we set 2 when we saved it, but we didn't set the other value we're going to multiply by. Only when we ran the function. It turns out, folks, we may also want to only determine some of our actual functionality when we run our function and leave it TBD until then. And that's going to be our very, very first part of our functional programming paradigm. But we'll see it in a moment. For now, let's just stress again. When you execute, when you do a function, Virginia, which symbols say execute a function? Parentheses. Thank you, Virginia. We create a new execution context comprising the thread of execution. That just now means we go through the code of the function line by line. I don't always write it all out, but know we're going through its code. And a little local memory, they call it local because it's only inside the function. It's also temporary. If we exit that function, except as we'll see this afternoon, it's temporary memory. It gets deleted, except for the returned out value. They often call it the variable, well, no one calls it variable environment. If you want to be really fancy, they call it the variable environment. Environment is the stuff around me. This is my environment. And these are the variables that are around me while I'm in this function. Yep, good. Okay, one final piece I want to add before we dive into functional programming itself.